Alright, so the first concept we're going to go over is projectile motion. So basically, if I wanted to cast at that wall over there, I would have to go through the casting motion and release perfectly where I want it to land. So this is going for the wall. Pretty close, pretty close. I'll do another example again. So let's say I wanted to go to those branches over there. I have to put a little bit more power into it. Go through the same casting motion. Boom. That was pretty good. Alright, so to sum up projectile motion, when I'm casting the bobber out, it's going in the direction of the Earth's surface, and at the same time, the force of gravity is acting upon the bobber.
I'll be demonstrating air resistance, and so I will be aiming at the patch of leaves over there, and like so. Okay.
That was close.
Now, it wasn't completely accurate because the air, as I threw the bobber out, would affect the line and the bobber at the same time, resisting against it, making it not completely accurate, which is what air resistance does when fishing. Okay, so air resistance affects long-term projectile motion objects more. So basically, if I were to cast the bobber farther, the air resistance would affect it more, making it more inaccurate. And if I were to do it like a short distance, I would be able to know where it would go a lot easier. Yeah.
Alright, so GPE occurs when casting a fishing line because the line reaches its max altitude, and at that point the hook and line both have GPE. So when I cast this line, right when it gets to that top point by the bridge, that's both the hook and the bobber have GPE right when it's falling down from the max altitude.
Okay, so GP is equal to mgh, and what affects GP is the mass, the g, which is the force of gravity acting upon the object when it comes down, and the height of the object when it reaches its top limit, and then it starts coming down. So when you go out, you see the bobber and the hook hit the top of its point altitude, and right at that point, before it starts coming down, it has gravitational potential energy.
Okay, so fishing can also relate to rotational motion by the line spinning off from the reel. So when you do have a fish on, you want to try to have a consistent cycles per second when reeling in the fish. Otherwise, there's a better chance of the fish getting off the hook. So if you cast out, and let's say you have a fish on and you start reeling in super fast and slow down and then super fast, there's a chance the fish will come off. So what you want to do is have a consistent cycles per second when reeling up the fish at a nice constant speed.
Okay, so the last topic we're going to be discussing is tension, and so when you have your line in the water and you're waiting for a fish, the bigger the fish is, the more tension on the line, and like if I'm waiting here for a fish, tension can affect the line a lot by the weight of it, and the more tension on the line, the more likely it is to break. So you have to keep your cycles per second with your reeling at a continuous rate, or the line may break at any point, which is why the bigger the fish, the more likely the line is to snap.
Okay, so basically what Jack was saying, when you cast your line out and you get a fish on, the bigger the fish is, the more tension there will be, and the smaller the fish is, the less pull there will be. So let's try to catch a fish. Alright, there we go. Small bluegill.
Nice.
Alright, so we have a little small bluegill right here. And so basically, it took me like 2 seconds to reel in the fish because it's less than a pound. So like I was saying, the smaller the fish is, the less tension there will be, and the easier it will be to reel it up. So, yep. There we go.
Nice.
You got one? Yeah. You feel the tension on there? Oh yeah. Make sure you keep it consistent cycles per second. There you go. Oh yeah. Nice one. Yeah. Nice fish, Jack.